Time to start the friction lab. The first part of this lab is done on a horizontal plane. And these are all the things you're going to need. You're going to need your block with the recess in it to hold the cans. If you don't have cans, you can use something else. It doesn't matter. As long as we have a range of, say, maybe 1.5 newtons to 4 newtons, 5 newtons, and you'll be able to combine them in different amounts. You're going to need the green spring scale and the red spring scale. Now, when you go to get started, you're going to want to weigh everything. So you're going to need to weigh the block, and you can use the paper clip to weigh each one of these cans. And before you start, you want to make sure that the block is clean. Wipe it off with your hands. Get rid of any dust that might have accumulated on this board. That will change the results. Now we'll start with a block with nothing on it. As I pull, you might notice that the block is not moving, but I'm definitely exerting a force. What's keeping that block from moving? I'm pulling this way. Something must be going backwards. Yeah, that's the friction. The block is pretty light, so you're not going to get a whole lot of friction. Let's see what happens as we try to move this. I pull harder and harder, and it starts to move. Well, you're going to get better results in this lab if when you put the block down, you push down on a little bit and make sure it's making good contact. There's a little layer of air, a little undulations. Push down until make sure it's well seated. Now we try to pull. As we pull, our force increases. Well, so must the friction if the block doesn't move. We soon reach a point where my force causes the block to move forward. Well, then we must have reached the maximum friction going the other way. If this friction is applied to the block when it's not moving, we call it static friction. We're also going to study friction when the block is moving, and that's kinetic friction. So I'm going to pull slowly, ever so slowly, increasing the force. All of a sudden, we reach a maximum, and the block jumps forward. That's when we've reached the maximum static friction, holding the block back. In this close-up, you might be able to see a little better how it jumps forward. You want to record the maximum force in the spring scale just when that block jumps forward. Now we can do it again with additional weight. Again, before I start, I'm going to push down on the block to make sure it's seated well against the surface. As you can see, we had to pull a lot harder to get it going. You might have to do this a few times. Any type of vibration, or if this block is not seated properly, it's going to release prematurely and your data will be off. So maybe you want to do it a few times, reset it back in the same place, and do it over again, and maybe take an average of those values. And then, of course, we can put 2 cans in there, try it again, and then we can put a large can and do it again. You can do it with a large and a small. You can load the whole thing up and try it all over again. So here we have a diagram of the apparatus. And now we'll draw the free body diagram. We have the weight going down, the normal force from the plane pushing up, and that's me pulling to the right. If the block remains at rest, we know the forces have to add up to 0, so there must be a force going to the left. And that's the force of friction. If the block doesn't move, we call that static friction. If I pull harder, friction pulls harder. But eventually, when I pull hard enough, we reach a maximum amount that the static friction can pull back with. At that point, the static friction releases, the block lurches forward. While the block lurches forward, we call this kinetic friction. It's smaller than the maximum static. Well, in the first part of this lab, you're going to collect data on the maximum static friction versus the normal force. You change the normal force by adding weights. Now, don't forget the normal force is equal to the weight of the block plus whatever weights you put on top. Then you're going to plot this data on a graph. In part 2 of the lab, we're going to study the kinetic friction. But first, wipe off your board again. Make sure there's no dust that's accumulated. That'll act like little ball bearings and it'll change all the data. Now, when you go to pull on this thing, you want it not to lurch forward, but you might have to tap it a little and just get it to move at a constant slow speed and read that number. Now, let's think about that for a second. What does that number tell us? There's a force pulling this way, but there's still a force pulling back. How do I know? Even though we're moving, there's still a force of friction going backwards. Well, if there wasn't a force of friction, this thing would start to speed up. There'd be nothing holding it back, and the force would accelerate the object. Now imagine we're moving at a constant speed, and now I ease up on the spring scale. I don't pull as hard. The block comes to a stop. How come? The force of friction was bigger than the force I'm pulling with, and it made it slow down. So if the force that I'm pulling with is bigger than the friction, it'll speed up. If the force that I'm pulling with is less than the force of friction, it slows down. Well, then what do you think is going to happen if it's going at a constant velocity? The force that I'm pulling with is equal to the force of friction holding it back. So when you do this part of the lab on kinetic friction, you just gently start it moving at a constant speed, read that number. That will be your kinetic force of friction. Then we do it again with a weight, another weight, more weights. And if the green spring scale bottoms out, well then that's why we use the red one. Now on the same graph, we can take the data collected for the kinetic friction and graph it here as well, so we can compare the difference between the trend in kinetic friction versus static friction maximum. Well, that's as far as we can go with this video because we don't want to give anything away. You get those graphs going, and then we'll talk about the analysis of the data. You can see more details in the Friction Lab handout, and you can also read the chapter notes on friction. Don't read those notes until you try the lab first.